Okay, line V1, we are in learning task number 9, where we are going to take a look at reversing motor starters. And what I want to tell you about on this one before we begin taking a look at anything is you're not going to understand the three-phase motor yet. You don't need to understand the three-phase motor yet. You just need to know how to go and operate the three-phase motor at this point. And that's really what we're going to go and do over here. We're going to go and explain something just to the level of operationalness, and then after that, you'll get the deep theory inside of your third year. It's kind of like my liver. I don't understand how that thing works, but I just know that I should not be drinking excessively or else my liver starts to hurt again. So, that's what we're doing with this, is that we're just taking a look at something and we're only going to understand it as far as we need to know how to properly operate it. Okay, this over here is going to be a three-phase motor. We are not going to talk about what makes a three-phase motor, but it's a motor that has got 3 power lines to it. You may have heard of these systems before, 208/120. Remember, high voltage first, then low designates this thing as being a three-phase system. Sometimes you'll see a Y that's going to be placed behind that. We'll explain all of that in third year as well. But what it is it's a specialized type of system where I've got voltage on all 3 lines. And those 3 lines are actually going to go and get color-coded as red, black, and blue. Always, always, always. Red, black, blue, red, black, blue. And so what we can do with a three-phase motor is going to be using the windings that are inside. They're a form of inductor that is going to go across to the central rotor, which is also like another side of a transformer. Remember how we talked about back in inductors that we need the inductor theory for transformers, the transformer theories we're going to need for all of our motor later on. So it's basically going to create a transformer circuit in the center over here that's going to set up magnetic poles, and then those magnetic poles are going to go and interact. We're back to year 1 stuff, magnetism, which is then going to go and rip this motor around in the direction of rotation. All that I can do to reverse it is just reverse any of my 2 incoming lines, and that's going to reverse the direction that the magnetic field is moving. If it was going counterclockwise before, we can reverse it, so it is going to go clockwise. Now, this over here, the line A to T1, line 2, or line B to T2, etc., all of those, numbers to the letters, don't stress about that. If you put a line A to a T1 and a line B to a T2 and a line C to a T3, not every system is going to be counterclockwise, nor is every system going to be clockwise. That's always going to be based upon the way that you as the electrician have put it together and the way that the motor winder put the motor together. So oftentimes when we're starting these motors up, we don't really know which direction they're going to be turning. You can use a proper phase meter and rotate the shaft by hand to figure that out if it's something really critical. But if it's a non-critical load, usually what we'll do is we will go and bump the motor, as we call it, which means that we're going to provide power to it. We're going to have somebody watching the motor. We'll just give it a quick start, and we'll see, does this thing turn the direction that we want it to go. If it does, perfect. If not, we have to reverse it, and the reversal process is super, super simple. What we have to do is we have to interchange any 2 of the lines. See how the T1 over here was up to A before? They're now moving that thing down to B. And the A, they're moving over to the T2. As soon as they do that, that reverses the motor. I should point out that this is a non-standard way of rotating. Although any 2 lines, interchange of any 2 lines, will actually operate this, what is commonly done, the most common method, is that my line A and my line C are supposed to be the ones that are going to go and interchange. So if I were to go and look at this drawing over here, we'll just leave that there. Like that. What we would normally have is that line A would interchange with C, and line C would interchange with line A, and then line B stays the same. This is just because we have got 2 main forms of rotation that are called A, B, C rotation. That's a phase rotation that we would designate, or C, B, A rotation. Now, if you take a look at either of these, you should instantly recognize that the B stays in the same spots, the A and the C that have reverse. So the proper way to change it is always interchange A and C. But if you interchange any other 2 lines, you could interchange B and C or A and B, it's still going to go and work. You're just, not working the way that most of us are working. This is not a matter of being creative. This is just a matter of not doing it proper, quite honestly. All right. Let's take a look at how we reverse that inside of a contactor. I'm going to go and use 3 different highlighters here that I'm going to go and bring up to lines, okay? We're going to start actually by just highlighting the line 1 in the color red because it is always seen as being my red phase, my A phase. I have got my B phase, which is going to be my black. This is straight out of the code, that it's always going to go and be the black. And then the C phase, which is always going to go and be the blue. I'm not using the hops off of this one just because we're trying to keep this as clean and neat as possible. We've got the color coding so we can tell what's what over here. What we have over here is 2 separate contactors. There is one contactor that is this one over here. We're going to call that our forward contactor. There's another contactor over here, that one we are going to go and call our reverse contactor over here. Side by side contactors that we have over here. We then carry a line over to our motor. We're going to start up top over here with our forward one. We see that we have got the red line over to the motor. We can do the blue, or so the B phase, the black line over to the motor, and I can take the C phase, which is going to be my blue line, over to the motor as well. And then if I take a look over here, I can follow my blue line goes down to there, and my red line goes down to there, and my black line goes down to there. What you should see, if we just examine the top contactor, okay, we're just going to take a look at the forward contactor here right now, is that if that contact were to go and close, we would have a line A to a line A to a red line, you know, black to black, blue to blue, that we would connect through to the motor, so that motor would start in my forward direction. If I turn this one off, forward here, and then I close in my reverse, we would see that I am going to go and have black still going over to black on the motor, but now I'm going to have red, that's my A phase, going over to my blue, that's my C phase. So A and C have interchanged over there, as well as I'm going to have blue going over to my red phase over here. We have changed from ABC rotation to CBA rotation on our motor. This is the proper way for us to go and do that. Now, there is a great danger in doing forward reversing with these contactors, and the really, really big bad danger would be if I manage to close both contactors at the same time. Let's just highlight what would happen. Okay, I'm going to close both of these simultaneously. I'm just going to remove those boxes there because we don't need those so much. I want to take a look at my line A. If I take a look at line A, I see that line A is directly able to short back up to my line C over there. That's going to be a terrible thing. In fact, it's got 2 parallel short paths, right? Like that we are going to go and have. And my B is going to be completely fine, but it's that whole line A to line C short that we're seeing over here is going to be absolutely destructive. My motor's never even going to turn on. Current's going to go and take the path of least resistance, and the path of least resistance is just to go and flow a ton of amps through that so that it can try to establish a voltage drop. It's not going to. We're just going to get an explosion inside of the cabinet. So this is a danger that we have to go and prevent. We're not going to prevent it by not doing this. We still need to go and reverse the motors. That's just, you know, part of industry. Stuff needs to go forward, stuff needs to go backwards. So we're still going to go and reverse motors. But what we are going to do is we are going to go and make sure that there's going to be some mechanical protection between these two that is going to go and prevent them from going and pushing together. Do you remember when we were taking a look at those early push buttons, how we had one push button that would push in and the other one that would go and push out? We call that a mechanical interlock. Think about it as a seesaw, and that's literally what's happening inside of these 2 contactors. These 2 contactors are going to be held together with a seesaw, so that the contact points that are on one side, we will, you know, call this thing the, I don't care which one it is, but one of my contact points that I'm going to have over here, and then we're going to have another one on my reverse one that's going to be over here. And as soon as one of these would get energized, that seesaw would tilt, pushing that one up, but making sure that that one is pulled down and away. It's going to be impossible for it to go and operate. These are all done through kits. Okay, that's a simplified, you know, concept of what the kits do, but the kits are all going to go and have a little seesaw piece that is going to be used to physically bond two contactors together so that when the coil is pushed down on one, you cannot push the coil down on the other. It's also going to prevent it from not just, when we provide power to the coil, but it's going to prevent us from actually taking our screwdriver and pressing in the armature. You cannot physically press the armature in on one of these contactors. If it's running in forward, you can't press in the reverse if it's got the mechanical interlock. It is your responsibility as an electrician to provide that. Okay, it does not come from the manufacturer. Sometimes you can buy them as pre-made starter kits, but you need to make sure that you're aware of it. You are putting that thing in. Okay, let's talk then about how we develop the next part of the circuit. This was the power part of the circuit over here. Let's talk about looking at the control part of the circuit. The way that they're going to develop the control circuit is they're just going to go and develop 2 3-wire circuits. And that's what the steps are, that they're going through over here. They're saying, hey, look, what we can do is we can build our first circuit here as a standard 3-wire circuit. We are going to go and have my forward coil. We are going to go and have my seal-in contact for the forward coil. We will have the forward push button, and it's all in line with the stop push button. And then they say, well, we've got that done. Let's now add on another section. And so they add on the reverse one. They put it in line with the same stop. So if you take a look, it is the same type of circuit. They're stacking this thing on behind the stop there. But I see that I have got a push button, a contact, like the auxiliary contact, and a coil that are all going to be tied together. That's what we have with these two here so far. The last thing that we are going to go and do is we are going to go and provide an electrical interlock. And the electrical interlock is something new that we haven't taken a look at, but it's where on our coils we are going to go and have that forward and reverse, tied together. We need to have some way to prevent us from providing power to the coil. Because despite the fact that these two coils are supposed to be mechanically interlocked, that could fail. So we want to have a backup system, which is going to be the electrical interlock, which would prevent us from energizing one of the other coils if a previous coil is connected in. That's what we're doing over here. You'll note that my reverse is going to go and have an electrical interlock up into the forward. And my forward is going to have an electrical interlock down into the reverse line over here. You'll also note that these two are normally closed types of contact. And a normally closed type of contact really just means that it's just until we go and provide power, it's not going to do anything. It's going to be there as an actual provided path. I'm just going to zoom in on this one here. Oh, whoa, way too much zoom. Enhance. Enhance. All right, there. Come on. There we are. Let's go through this one now in detail. We're going to operate it into both forward. We're going to operate it into reverse. Same deal as what we did before. We are going to go and provide power up to the far side of each of these. I know it's really big and nasty looking on here because we're so zoomed in and the highlighter doesn't get any smaller. There is that little section. You see that little wishbone-shaped connection that we have in between the forward and reverse over there with the dotted lines? That's going to go and stand for the mechanical interlock. You got to be drawing that on your circuit. You got to be showing that that's an actual part of it. Let's go and take a look over here. This is going to be my stop. I see that I can carry power through up to there and up to there. I see that I can carry power through up to there and up to there. And at this point, my circuit at rest is ready to go. Let's start by pressing forward. When we press forward, we are then going to allow current to go and flow. Current is going to flow through the normally closed contact of my reverse contactor, right? We haven't activated that contactor, so there would be absolutely no reason for that to be open at this point. Its default at-rest state is closed, so we're going to be able to flow current through. We then energize this coil. When we energize this coil, two things happen. We open this up over here, and we close this over here. This one closing allows us to go and seal in over here. We can take our finger off that push button, and we are going to be operational. This one down here prevents us from being able to energize in the opposite direction. Take a look at this. If somebody were to go and press the reverse button over there and provide, we're running it forward right now, and try to provide power, it would only be able to get up to there. It's being blocked at that point. Absolutely cannot go and get through, so we cannot energize the reverse coil while the forward coil is running. It's a beautiful, beautiful thing. At this point, if we press the stop button, it's going to go and interrupt all of our current, and it's going to go and shut, the thing down. Take that off. This one would return to its at-rest state over there. And when we take our finger back off the stop button, we would have power back down to where we left it off before. We'll press reverse. We're going to get the exact same operation. The reverse is going to go and make contact. It's going to flow through the forward, normally closed interlock, all the way up to the coil. And the coil is going to energize. When that coil energizes, it's going to go and open this one, and it is going to close that one over there. When this one closes, my sealing contact, that is going to go and seal in power to that coil, and I can take my finger off that reverse button. We would be running in reverse. Same deal if somebody were to press this button at this point. Well, it's already running in reverse, and they tried to run this thing into forward. What would happen is that power would be carried up to here, but it would never actually be able to hit the coil and do anything there. We've got our electrical interlock over here that is preventing the energization of the coil. The electrical interlock prevents energization of the coil. The mechanical interlock prevents the movement of the coil, of the armature, I should say. Okay, we will once again interrupt current. We can interrupt the current off of the stop push button over here. The other way that we could go and interrupt it would be through my set of overload relays. The overload relays are not shown inside here, but they should be drawn in over there. On that one, either one of those, the stop or the overload relay, is going to interrupt all current into this circuit. Let's kick it out on the overload. So we can open that up, which would interrupt this, which would drop that out, which would reverse those ones. We would go back to our at-rest positions over here. Beautiful. Let's reset that overload. We're back in business. There we are. Note that on my circuits themselves, there is only one set of overload relay heaters inside the motor, right? If I take a look at the motor, that's the motor over there. We see that that overload relay inside is going to be made up of one single set of heaters that are going to be going out to one single set of overload relays. They have them drawn in up top there. We just add them into that bottom one just so we would be able to go and see that. Okay, let's go on to the very last one over here. Things are getting a slight bit more complex, but not terribly so. I don't think this is beyond your area of comprehension at all. We're going to start, before we start, freaking out about what's going on inside of here, I'm going to start by just looking for the guts of the circuit. What is this circuit actually to me? If I were to erase this, and I'm doing it mentally, but I'll do it physically on here, if I were to look at this, I would be able to say that, hey, this circuit that I'm seeing inside of here looks just like a standard forward reversing circuit. Looking just at that section over there, I see I've got a forward push button. I've got a forward interlock underneath that, and I see I've got that reverse electrical interlock behind that one there as well. And on the reverse side, we've got the same thing. We've got the reverse sealing contact, and then we have got the forward interlock that's in line with that coil. So the guts of this are exactly identical to the circuits that we had just gone through. This just means that if I press my forward push button, that I'm going to go and get forward operation, and that this coil over here is going to be locked out, and vice versa off of there. What we can do now is we can start adding in, bit by bit, these other components and just looking at where their connections are going to be. Let's start with this top one over here. If I look at this, I see that I'm going to go and have a red light. Now, the fact that they've got an R inside of this one is a little bit confusing because the R makes it look like it's a light that indicates when we are going into reverse. That's not what this thing is over here. This light over here is just going to be a red light, and if I take a look at it, it's got a connection point that is spanning across here. It is in parallel with my forward. The only time that this thing would be energized is if I am going to be running in forward, or if I've got power that is being pushed through into my forward position. So this one has got an R. You can cross it out if you want and just write an F next to it so it's easier to understand, but that's going to be my forward light itself. Let's just carry that current through real quick to see what this thing actually looks like. Up to there. When we press our forward push button, we are then going to deliver current through the normally closed interlock up to the coil. The coil is going to go and energize. When the coil goes and energizes, it is going to go and send sealant current over there. And we see that as soon as we've got this node over here energized, current is also going to flow out to that light, which is going to go and turn that light on. And what we can do is we can take your finger off the push button. We're going to have a light that's going to indicate that we are in the forward running position. If I go and stop this, I can hit my stop over there. We'll interrupt all of that current. All of these are going to go and shut off over here. Okay, let's go down to the bottom. We're going to take a look at the next rung that we have over there. Oh, I erased everything there. Hold on, we're just going to go and take some of this out right now. We're doing it step at a time over here. We're going to start with just this one in here right now. If I take a look at this, I can trace my line 2 up to the other side of this one here. That A stands for an amber light that we are going to go and have. And I can see that it is tied so that it's going to be in parallel with this, right? Once I get power through up to my reverse coil, this light is also going to go and turn on. Once again, we'll just quickly step through it here. If I press that push button over here, I am then going to go and have current that's going to deliver through to my reverse contactor over here. The reverse contactor is going to go and energize. It is going to go and close that set of interlocks over there, which is going to go and send sealant current up to here. And at the same time, it is going to go and send sealant current over to this light over here. I take my finger off that push button, and we see that we are back in business. We are now running in reverse, and we have got a different colored light that is activated and telling me that I'm running in reverse. I do want to point something out on this circuit, and it's something that could be good or could be bad. I'm not saying it's a terrible thing. I'm saying it's something you'd want to really think about, anytime that you would be operating one of these. If somebody at this point were to try to operate the motor in forward, it obviously would not operate because the reverse coil is energized, so this over here is blocking us from hitting that coil, right? The electrical interlock is blocking that. But if somebody does press the forward push button over here, you'll note that I can still provide current over to my forward light to show that somebody is calling for a forward, control off of this thing. This could be good if I've got more than one push button station in a facility. I could have, that somebody is at station A, they're running it in reverse, and somebody else is trying to run it in forward from station B. This would just let me know at any one of my stations that somebody else is calling for it. But it's not really a good thing because it makes it a bit ambiguous as to which mode itself it's actually running in. Same with this one down here. This one would operate the exact same thing. If we're in forward, we'd be locked out over there, but we would still be able to activate the light itself. The better methodology for these would be that if these lights themselves were to be inserted between the interlock and the motor. If I were to insert the lights like that between the interlock and the motor, at that point, if somebody were to go and press this forward push button, none of that current could get through to the light, none of that current could get through to the coil there as well. So we would have just a better type of operation. It's not a big deal, but it's the type of thing that, for myself as an industry professional, bothers me when I take a look at it. You go, why? Why would you do that? Anyways, we will go and leave it alone because that's what they have inside of the book. The whole thing that we were trying to go through was just this operation that we have with these ones. The last circuit that we have over here is going to go and have two normally closed sets of contact. One that's going to be tied to my forward coil, one that is going to be tied to my reverse coil. So I'm going to go and have this light that is going to always be receiving power anytime that I don't have any coil energized. As soon as I would energize any coil, if we were to energize the forward coil, then it would go and take that current out and would shut that light off. Same if we would do the reverse. So really this bottom rung that we have over here is just a ready light that we would have. If I had to give names to each of these lights that I saw in here, I would call this thing FWD, forward. I would call this thing REV, reverse light. And I would call this thing over here ready or stopped. Because that's really what it's telling me, that the system is ready to go because it's stopped, or that the system is stopped. Either one of those would give you a proper one. Once again, the letters that are inside of here have nothing to do with who they're tied with. Those are just indicating the colors. This is very common on electrical schematics, that anything that's a red light will get the R. A is going to be amber, that's what we call yellow. and then, or orangey, yellow, whatever you want to call it. G is going to be for a green light. Green, by the way, is oftentimes used for safe. Red and orange mean that the system is activated and that it's, dangerous. All right, that is it for our reversing starters. Don't think there's anything more I want to go and talk about. Yeah, nothing more that I really need to go and talk about inside of here. Cool.